So now I don't think I ever made this mistake before, but I'll recreate it for you. So I am pretty sure I accidentally wired these backwards. I think I unwired them before I noticed what I probably did wrong. But in case, the LEDs didn't light up like they were supposed to. And we got the maximum current I got set there, 20 milliamps of current. That's why I set a maximum. This circuit I know is going to be under 20 milliamps of current when it's wired properly. So we know something's wrong. I thought I had a short circuit or something, and I unplugged the power just in case. But the way I had the cords, I noticed that I probably swapped these so that they were backwards. So that side should be negative, and this side should be positive. And then once I got it wired right, now it's or the power right, it looks like it's wired right. So low output until I press that button, high output until I press that button. And we're back to about as much current as we should have. So now we're going to take a short look at the 555 timer in bistable mode. Going to stay high until I press that button. Now it's going to stay low until I press that button. Both states are stable until I press a button. We got to power the 555, positive supply to 8, negative supply to pin 1. We got the threshold pin. I bumped the power supply, that's why it switched. We got the threshold pin to ground to prevent it from doing anything. So now we got a low output. Both of these inputs have a pull-up resistor keeping up positive voltage. We need a low voltage in order to change it. So that one goes to the trigger pin right there, which sets the output high. When you press that button, make a connection to ground. Now for the reset pin, we also have a connection to ground, but only once I press the button. It's being held high, and that moves it back to the output being low. So you can see the positive supply there. Keep in mind we got the long lead, the anode lower, short lead, the cathode there. 1000 ohm resistor, 220 ohm resistor protecting the red LED. So now we're going to take a short look at the 555 timer in monostable mode. It's going to stay low, mono, until I press the button. But it's only high for the period of time we set over there. It goes back to our stable state. Of course, we have to power the 555 as always. That's 5 volts. Positive supply to 8, negative supply to 1 there. We're disabling the reset pin by putting it to the positive supply. It's not doing anything. So we got the reset button there. It's being held high, pull up resistor 10K until I press the button. Then we get a low input. If I keep holding the button, the output's going to stay high until I release it right there. Otherwise, we got the timing set by over here a 10K resistor and a capacitor. While it's charging, the output is high. Once it gets to 2/3 of the supply voltage, the output goes low, blue LED lights up, and the capacitor discharges. 1000 ohm resistor to protect the blue LED from 5 volts, and 220 ohm resistor to protect the red LED from up to 5 volts. So now in this video we're going to take a short look at the 555 timer in astable mode. There's no stable state, it keeps going back and forth. We're using 5 volts, which does not affect the timing, but you have to put the pin 8 to the positive supply and then pin 1 to the negative supply over there. Pin number 4, reset pin, we don't want it to do anything, so we're going to the positive supply. Well, we're charging and the output is high. We got 10K resistor there, a diode, 100 microfarad capacitor there. That affects the timing. Well, the output's low. We got a discharge through a 10K resistor right there. That also affects the timing. Since they're equal value resistors and we got a diode there, should be about equal timing. So pin 2 and pin 6 monitor those voltages. Pin 6 sets the output low when you get up to 2/3 supply voltage. Pin 2 sets the output high when it gets down to 1/3 supply voltage. Make sure you put the blue LED in the right way so it'll light up. 1K resistor because we got 5 volts, and 220 ohm resistor because we got 5 volts. So now we're going to take a short look at the 555 timer wired as a Schmitt trigger inverter. We got the positive supply, low output. Get below 1/3 of the power supply, we got a high output. Got to go back up to above 2/3 of the power supply, we get back to a low output right there. So we have to power the 555 timer, positive supply to pin 8 and negative supply to pin 1. We're disabling the reset pin. We don't want it to do anything, so we are at the positive supply. So pin 6 detects the 2/3 or higher voltage, which we have there, and it sets the output low. Pin 2, they're tied together, is waiting for 1/3 or less of the supply voltage, where it sets the output high. So you can see positives coming out, 220 ohm resistor, because we're using 5 volts. Long lead, anode, short lead, cathode down there. Blue LED, we got the long lead down lower right there. Cathode up there. 1000 ohm resistor, again 5 volts. So that way it lights up when the output connects to ground, or low. So now, In many of my videos, you see a blue LED and red LED that are in series basically, and they got their own resistor for a lot of resistance. Blue LED passing the same as the red LED, they're just a lot brighter with the same amount of current. But generally you see me with something else attached to them, so it's usually the output of something else. And when I say the output is high, the red LED lights up. So we got a direct connection to the positive supply. Now you can see the red LED lights up. You can see that current path there headed to ground. That's what I mean. And when I say the output of something else is low, that means it makes a direct connection to the negative supply. And the red, or the blue LED I mean, will light up just like that. So I'm using 5 volts at the power supply there. So 1000 ohm resistor to protect the blue LED because it's brighter, and a 220 ohm resistor to protect the red LED because it needs more current to get as bright as the blue LED.